Given the environment and the method of disinfecting the virus, we propose a new robot capable of spraying disinfectant over a confined space. At the beginning stage, we aim to gain some basic insight of problem context and produce a draft idea of what would the robot be like. We want to target COVID-19 and reduce the possibility of infection in an automatic, effective, and thorough manner. If we sit in private room all day long, we're certainly safe, but we need to interact with others. We need to clean the environment thoroughly in a three-dimensional way. We did some research about the most common infection environment and the spreading method of COVID-19. It turned out most infection cases happens indoor because the virus is spreading as flood droplets and resting at the surface of furniture, while the wind outdoor can blow away the virus quickly. Therefore, indoor is our target environment. The robot should be small enough to fit through narrow spaces. We might add pathfinding to avoid damaging furniture. The most common practice of disinfecting in the public area is spraying disinfectant. It is easy to use, cheap, and relatively safe. However, it's labor-intensive and exposes operators to risk of infection. Carrying the heavy equipment, operators may not be able to work for extended time. They may spray more than needed. So our goals are automated, efficient, and smart. Different ways are available for creating nebulization. Right now, we give out 4 sets of combination to create spray. First set is ultrasound with air current creating by fan. Second set is using mechanical vibration to create spray and air current for guiding the spray. Third set is using water pump to create high pressure flow and passing through liquid nozzle. The last one is gas-assisted nozzle. In the next stage, we will focus on the efficiency of these 4 sets of systems. Determine whether it will meet the requirement like easy to control the spray, the size of the system, the dimension of the spray meet the requirement, and the cost of the system. During further development, we decided to use water pump and nozzle. At the beginning, we decided to use ultrasound as the atomizer. However, we realized that it might be harmful with our design because the ultrasound atomizer will produce the mist that might be inhalation by user. The use of air current to control the mist are relatively imprecise that might spray the disinfectant on object we don't want to. In this way, we decided to choose from gas-assisted nozzle and the combination of water pump and nozzle. Our aiming is to produce an auto machine that can disinfect the whole house by itself. In this case, long working hour would be necessary. The size of gas tank which is sufficient would require a lot of space for storing. So at last we decided to use water pump as our power source and add nozzle at the end of the path to produce mist. In order to achieve precise spraying, the robot should travel with wheels or propellers. Since there are already various mature solutions of indoor robots using them, the nozzle should be able to spin and the angle of elevation should be adjustable to enlarge the spraying range as far as possible. The nozzle should also be lifted to a certain height so it could spray on tables and chairs. In the end, we decided to use the car form. In terms of other features, there will be camera and GPS used for route planning, and a replaceable water tank, which is separated from moist production chamber, would be used. On the second stage, we started to look at design details that is more technical. It is important to find a proper way for a robot to clean the area in 3 dimensions. This will come with the discussion of degrees of freedom. The first gen of our consideration is using propellers or using a base with wheels that can move around. Although the wheeled version can only move on the ground, which means its motion will be blocked easily. While the height is not a limiting factor for propellers, the wheeled chassis are usually simple and reliable, while the propeller ones are of complicated implementation, less working duration, and higher risk to damage furniture and drone itself. We choose the wheeled chassis, and a route planning program will be used. This is a material list that will be used in our project. An Arduino Uno acts as a bridge to manage motors and receive commands from the host machine. Raspberry Pi is the host machine, and it not only does heavy computation but also communicates with remote controllers and other devices in the local area network. We use 2-step motors and 4 wheels for basic movement. On top of the chassis, placed a water tank, a DC motor pump that pressures disinfection water through a brass nozzle to spray out, 1 brushless DC motor to rotate and pitch axis. All of the motors are driven by L298 and driver board and powered by several 18,650 Li-ion batteries. We use both GPS and gyro to locate its location in the room. When signal is weak or precision of GPS cannot meet our standard, we estimate our location with acceleration and rotation provided by gyro module. We also use a camera to avoid obstacles in the room, aim for the target and distinguish items that should be disinfected with help from deep learning on board. It also provides a closed-loop feedback for movement and targeting. We also have a backup plan if the above is too difficult to implement. Use semi-auto control with obstacle avoidance algorithm built in. The nozzle would be able to rotate and elevate. driven by several motors. When the car finds a target in its view, it will use deep learning algorithm to decide or not to spray this object, and aim for this object with PID algorithm. The pan tilt should also be lifted vertically in order to disinfect the upper surface of tables and chairs. The first stage explains why we would make a spraying robot, what the requirements of the robot are, and why we prefer a wheeled solution instead of a flying solution. The second stage explains basic looking, materials, and rationales behind the pressurized nebulization method. It also covered a bit of nozzle movement. In this third stage, we will discuss the mechanical details of the nozzle movement, which is quite complex and intriguing. Since our machine works in an indoor environment, our robot has to deal with tables and chairs. To make the disinfection effective on the surface of tables and chairs, we need to raise the robot's nozzle to 1.2 m height, which requires a telescopic boom of a high dimension of freedom. The first draft of our design imagined creating a base, just like a camera stabilizer adding a nozzle. Due to the limited area indoor, it is tough to design a vertical guide rail that can lift the whole system, and the gravitational center will be too high to retain stability. Having a vertical pole to elevate only the base is not an elegant solution. So, in the next-gen design, we consider the structure of the firefighter truck. The scaling ladder can extend in a wide range and require relatively small storage space. Although the L298M provides a 5V output, we better use separate power supplies to control the motor and the control chip, which can avoid the current instability causing the L298N to be burned or the chip to be restarted. The chip restart happened on my previous project. Because of the urgency of time, I temporarily connected a capacitor in parallel to solve it, but this project should consider this problem more seriously. The chip should be Arduino Uno. Very classic. Since the robotic arm is a multi-level arm, operating it requires a lot of computing power and real-time closed-loop feedback. We delegate such computation to the Arduino Uno running FreeRTOS, whose purpose is to control specific and low-level hardware. A state-of-art motion planning library called the Open Motion Planning Library can help us achieve motion planning of such a multi-level arm. Besides that, we use a camera, OpenCV, and some other sensors as feedback to control the robotic arm more carefully. We also use PyTorch or Keras on Raspberry Pi to extract real-time gesture and position of the robot, and PID algorithm to control movement on Arduino. We have two concepts: the disinfection arm. This one is foldable more like a traditional robotic arm and a firefighter trunk, though relatively hard to make. The second one is more like an elevator and more realistic. Here's the draft design of the whole spraying robot. Ball screw rods and rails are used together to lift the nozzle stably. The nozzle arm, with 2 degrees of freedom, would allow the robot to spray from ideal positions and at an ideal angle. The omnidirectional wheeled chassis allows the robot to travel and spin at yaw axis freely.